Hello, this is Tay here. So now today, I just want to present our work which was included in this particular research work. So our title is Adapt to DoubleU-Net for Pothole Segmentation with Stagnant Water Detection. So let's see the main domain of this particular work. So with the increase in the usage of vehicles, potholes or the blocks on the roads is a critical problem. So the second most contributing factors to road accidents are potholes, and the third major causes for deaths or injuries in India is road accidents. So in order to solve this particular problem, as we know that neural networks in these days are booming in a way that they're finding solutions in each and every domain. So in this particular work, and in general, neural networks are one of the most used deep learning algorithms for image segmentation. So this is a contribution to automate the process of recognizing potholes with stagnant water. So the main problem statement of our work is potholes are one of the most contributing factors to road accident, especially for bikers, especially in the rainy season. These potholes are filled with rainwater, which are particularly dangerous. So adding to this, stagnant water in potholes can be suitable place for mosquitoes and other insects to breed, which is a dangerous cause to the health. So it would be possible to automate the detection of potholes and stagnant waters on the roads to had a better life. So this automation of the recognizing of potholes will reduce the fixing time, and it can also be integrated into self-driving cars as well. So the main objective of this particular work is to use deep learning methods to create an image segmentation algorithm to detect potholes even with water reflection. So in this, we have used artificial intelligence techniques, which it was aimed to automate the identification process, which provides results feasibly and accurately. So to implement these results, various algorithms such as WNet, ULO5, and which was WNet, which was modified by us, has been employed to achieve the best results. In order to analyze and evaluate and examine our results that are obtained from this net architectures, we have used some analytical techniques like F1 score, AUC curves, and other like precision recall. And using that particular values, we determine the best fit system for this particular automation process. So the main literature review of this particular work is, we can say it's like a limited or more than limited, but not more. So it mainly proposed techniques on how motion sensors and depth sensors such as Microsoft Kinetic can be employed to collect information about a particular location and dimension of potholes. And there is another work where they collected video footage of the roads, I mean the through drones and the cars. So later use this particular video footage to find out the potholes and locate that particular work. But anyway, they are unsuccessful in identifying potholes filled with water. So the main method which I used in this particular work is we created a deep learning model. So the data consists of images with potholes collected from various locations such as cities, rural areas, and different types of roads. So as we know that in deep learning, we'll divide the data into training and validation for reading or learning the algorithm process and testing to validate to test our, trained algorithm. And the data augmentation technique has been utilized to increase the data size, or which avoids insufficiency of data and reduce the threat of overfitting. So as I mentioned earlier, we have used different algorithm sets. To train our particular data. There's a segmentation architecture such as deep lab v3 unit WNet. Unit is a widely used architecture for semantic segmentation in images. So this is a modified double-unit architecture which we employed. Here, VG16 consists of 4 blocks of networks where it sends in the decoder block, and from that particular decoder block, it will encode a particular image and it generate a mask for which a pothole is present in a particular location. So the one which we have observed is from network 1 and network 2. There has been connections from these particular 2 blocks. So let's dive deep into the proposed work. So as we see earlier, there is a 3 into 3 convolution, which has an attention layer. So the output of each of the first four blocks in the VGC model before the pooling operation are taken as skip connections in the DoubleU-Net. So these skip connections are also used in the decoder of network 2 of DoubleU-Net. So the main output of this particular second convolution is the fifth block of VGC, which is considered as output for the encoder in the network 1, which is a DoubleU-Net. So the main decoder consists of three main layers. One is 2 into 2 upsampling and concatenating it with the squeeze and excite layers. And in concatenation layer, there are some skip connections. So we use atrial spatial pyramid pooling, which results in more efficient low-level representation of input, as it because of it shows the variable of FOV without much loss in the spatial features. So the results which we have got is the find proportion of exacting values. So the main results are WNet modified, which was modified for us with VGC16 as encoder, performs better with 0.86 a mean, outperforming all pre-existing models. So overall, all the approaches are able to perform better, but when comparison with accuracy, the time that was taken to train a particular, to generate a result of particular image, we got that the modified WNet has been, working pretty well. So, now, however, the proposed WNet model is on top of all of the models. As image data in the dataset is high quality with less noise, it helps to increase the performance of a particular models. So the fastest time which was took, or you can say the least time took to process an image is Deep Lab V3 just took 0.17 seconds to process. So these are all the results where a Deep Lab V3 is able to perform, generate a result in 0.17 seconds. But when you consider the accuracy and mean IOU, our modified WNet system is, overtaking all the other three algorithms. So in general, whether it was taking a more time or less time to, process an image, firstly, we need to, the first priority should be given to the accuracy. So because without accuracy, we can't really say that a particular system is effective to work in a particular scenario. So these are all the results which we have obtained, where this is the a first input which we have given, the first one, and the results that are generated by Deep Lab V3, and then the rest unit, and the last one is our modified network. So when you observe this particular one, you can clearly see the accuracy of our work. So in overall, a deep learning approach with modified WNet has been proposed in our system. To give attention to the output of convolution, squeeze, and excite layer was added in the architecture. So among all the models which we have used, WNet network performs better than Deep Lab V3 and SUNet. So although results are satisfactory, in future improvements such as increase in size of dataset, better annotations generated by subsets, and additional pre-processings of image can be performed. Thank you.